Hi friends, last class we seen about the basic of Ansys and how it's performed. So today we're going to see about the steps for analysis in any software. Okay, these are the basic steps. If we learn this means you can analyze in any software. These are the main three: pre-processor, solution, post-processor. So these three are major. If you know about these three means you can analyze in any software, not only Ansys, any software. So first of all, we go for pre-processor. In pre-processor, material, model, mesh, load, and constraints. These fees five are major in pre-processor. In material, we know about the linear, non-linear material. In model, 3D model, meshing, load, everything. So first we see about material and model. In material, there are linear and non-linear materials. So we generally tell about ductile and brittle. So in material, there is some yield strength for every material. So if it is ductile material means when it reaches the yield strength, then his break like glass. Okay, the non-linearity or ductile materials are something like when yield strength is belong that bit go for elasticity like iron. If you bend means it not break, but it's like a bend. Okay, within the elastic limit, it's deform its original state. If beyond the elasticity, it's deform its undeformed. So these are the non-linearity material. Then model we go for 1D, 2D and 3D models. So already we done in some of the modeling softwares, Creo, CATIA, something. So when importing model software like Step and IGS, after importing that we have to clean up the model. In case the unwanted holes, unwanted fillers, that's how we have to clean up. Okay, then only we perform the some easy method. While importing model, I can explain that clearly. Okay, these are the some first of all basic material and model. Okay, in material, some of the thing we have to know means the stress and the Young's modulus. So we have to mainly know the Young's modulus, Poisson ratio, and density. These are three major. Okay. Then we go for the meshing. There's a three type of meshing: 1D, 2D, and 3D. So in 1D mesh we have only rod element, beam element. Okay. We simply have cut into small pieces. Okay. If we have one rod means we cut into small pieces. It's called mesh. Okay. The 2 point is connecting is called node, and the line joining between two nodes is called element. Okay, in like that in 1D there's a simple rod and cut into small pieces. Okay, in 2D it's called quads and tries. When we have paper we cut into small pieces like square manner, it is called quads. In case we cut into triangle shape means it is called quads. For example, I draw some here. Okay, this called node. These 2 points are called node. Once again, open epic. Okay, these points are called node, and this called as a element. Okay, and here so same to the node and element. Here also when we connecting the node element like a tries and quads, like guys, the 3D model. For 3D there's a cube, and that means hexatetal and tetradominant. Like when we have cake, so we cut into small pieces means we cut like cube manner, is called hexadominant. And first of all we cut like a triangle shape, it's called tetrahedral. So these are the mesh majorly we used in while doing the modeling. I can clearly explain how it's performed and everything. Here I shown some example too, that we can clearly understand how it's performed. Okay, just see this model here. Okay, 3D mesh, and also we can done also in 2D mesh called symmetric and axis symmetric, and same as 3D as a symmetric and axis symmetric. Okay, while we checking how to check means we can check the element quality also. Element quality if higher or lower, so how it's perform, like that we can check. So in this model you can see the square cube with a full tetrahedral. Okay, it gives some perfect result because it has a perfect mesh. Okay, these are cube, but here you can like tetrahedral, like a full of triangle. Okay, what happens means here it becomes some abnormals. Like that we have serious everything. Here the sum of the chamfer here, so the tetrahedral becomes here. That means try is coming here for 2D. Like that we have to mesh the model and we use that. In upcoming classes like modeling I can explain, you can visually see that one. And third and finally load and constraint. So we already studied about simple supported beam, cantilever beam and everything. Here the same as in beam we give the force like force, pressure, these are called loads. The constraints are nothing but the fixed support or roller support, these are called constraints. Okay, that that are the major parts in the load and load and constraints. So here go for the solution and post processor. You can see everything here, geometry, connections, mesh, and static, structural, and solution. In solution, we have to know about which type of analysis you're going to do, static or thermal or model and everything here. On post processor, from the analysis, what result I have to get. Okay, from you can see from top to down. First of all, you get the model, mesh, static, structural, and solution. In solution, we get the result like total deformation and stress. This is our major result to find solution and stress. That means deformation and stress. Here some model I done in the Ansys, the modeling Creo. Okay, so this model, the simple model, we have model a chair and give material property and impose some force here and check the deformation of the body. So it is easier to change the material here, and in case we have to change also model, so it consumes less time and less cost, so that analyzing software prefer more. Okay friends, so this is a short explanations of the how to done steps of analysis here. Okay, next class we go for the model and deeply explain about that. Okay, bye.